Hi, my name is Bert and I'm the CEO of Tanktwo. Here at Tanktwo we strongly believe in the future of the electric car. There's no doubt about that the electrification of transport is one of the greatest opportunities of our era. And the disruption it is creating, it will be up there with the personal computer, with the internet, with the wireless phone and so on. And it's no coincidence that these technologies have been a great source of inspiration for the Tanktwo system. Anyone who has driven a Tesla will agree that electric cars are going to be a great opportunity for consumers. But it's not just a matter of making consumers happy, also there will be new business models that simply did not exist before. And of course there's another matter. You may or may not believe that climate change is a thing or whether or not we have passed peak oil already. But I think the following will hold true for everyone. And that is that when a better and cheaper technology becomes available for providing energy for transport, the market will vote with its wallet, and that the switch to electric will be automatic. I don't think that anybody will really miss the spark plugs or the timing belt or the check engine light. In the Tanktwo system, all the individual cells are smart, meaning they have a microprocessor, they can communicate, and they can adapt. We call those smart cells string cells. The capacity of the Tanktwo battery pack, which we call the string battery, is flexible, so you can more capacity when you need it, occasionally or for permanent use. And a smart system that is using commercially available battery chemistry can be in some cases drastically more efficient, typically in the 20 to 50% range, but in some cases it can be even more than that. And the key issue here is that optimization is an application of data science, and when you have a smart system, you can apply totally novel algorithms. Users can literally get a tank full of freshly charged string cells, and they can of course still charge their electric car like before, but if you want, swapping the cells, not the pack, is a very fast and effective way to get going again when you're out of juice. And about the timing, it's literally faster than getting a tank of gas. Tanktwo is primarily a technology licensing business, meaning that our business model is comparable to ARM or Qualcomm. But we also operate a back-end service because security and safety features rely on a trust-providing party. And what we do is not unlike the way that the SIM card works in your iPhone or Android device. Our go-to-market approach is doing a global launch. And we are currently on track of demonstrating the product, a fully functional Tanktwo-powered electric vehicle at CES 2017, the beginning of next year. And we will also intend on demonstrating the cell swap, as described earlier. At this moment, we are preparing for an A round. Tesla is doing a fantastic job at breaking through many barriers which were earlier considered to be unbreakable. The Model S is absolutely fantastic product, but for their business case to make sense, Tesla could only operate so far in the absolute top of the segment. History has shown that between 25,000 and 35,000 is a price point which certain people will pull up with. While here on the slide only the Nissan Leaf is a battery electric vehicle, the range gives an indication of what kind of elasticity that we will be dealing with. And in the upcoming Tesla Model 3, which Elon Musk has said will cost $35,000, also there this will be a fantastic success. The image on the slide here is an artist impression which I lifted from auto-moto.com. I think it's a very good looking drawing, and I really hope that the actual Model 3 will look like it. I really can't wait for it to come out. It turns out that people are willing to spend significantly less than the $35,000 which the Model 3 is expected to cost. And from the goodcar.badcar.com website, certain automotive retail statistics are available. When the car sales numbers are plotted on a histogram, as you can see here, and when they're matched with their publicly announced base price as of February 2016, a curve like this emerges. And this is, by the way, for cars only, so SUVs, vans and trucks are not included. But since the Model 3, it's a sedan, so that seems to make sense. And at $35,000 base price, a Tesla Model 3 would still be in the high-end car territory, not Tesla Model S kind of territory, but out of reach of most people regardless. And Tesla is counting on economies of scale to drive down the cost of the battery pack in particular. And as everybody knows, Tesla is currently building the world's most advanced battery plant in Nevada. And while that for sure will do wonders for the cell price that everybody will benefit from, it is probably not leaving a lot of room for profit for Tesla, which is, of course, their worry. Reportedly, Tesla loses over $4,000 per Model S that they sell, which will make it rather difficult for them to turn a profit on a $35,000 car. Everybody seems to agree that the battery is the most expensive component of an electric car, and therefore it's fair to say that it really is the cost of the battery that holds back the creation of a truly affordable electric vehicle. And the conclusion is clear, therefore the battery still costs too much for an electric car to become a true mass market product. Yeah, as it appears, as of today, February 2016, $145 is as low as you can get for a kilowatt hour of lithium-ion batteries if you're a tier 1 player and order about 1 billion cells. And based on numbers in the public domain provided by General Motors and several other players, it turns out that the expectation is that if the stars align and if enough volume is reached, that the price is expected to erode to about $100 per kilowatt hour around 2022, assuming that the market accepts the initial high price of the product of the cars and that the government subsidies for electric cars remain available. Unfortunately, a simple calculation reveals that even on this very aggressive price erosion path, we are still about $5,000 short to bring it within reach of a mid-range product. And even at that level, probably nobody is making any money. To make things worse, the price of lithium on the global market has recently been skyrocketing. Less than a year ago, it was at an all-time low, but it seems that all the analysts agree that this will never come back. And this will not make the price erosion target any easier to reach or any faster to get to. And it's not just a matter of bringing in more supply, because putting new mines online is a very slow process. And it's no wonder that Tesla has been hedging very aggressively and locking supplies for the next several years. And for the other players, it will make things then even tougher. And eventually the rising material price will provide a terminal floor for what the lithium cell price will stabilize at. Many car manufacturers have decided to enter the electric car game, not so much because they love to cannibalize their legacy product lines, but because of upcoming strict caps on emissions. And the recent climate conference in Paris was different from the previous ones in the sense that at this point there is no known technology that will make the internal combustion engine improve enough to be able to comply with the upcoming stricter targets. And therefore many OEMs have already stated that they have no choice but to put a certain amount of electric cars into their product mix. And very few technical alternatives are available, the sole exception perhaps being hydrogen. And although it would help in lowering fleet emissions for a while, there's no real long-term path for hydrogen as a sustainable supply. And for that reason, essentially only Toyota appears to have announced that they will follow that path. So at this point, even the automotive companies all seem to agree on the fact that electric is the way to go. For many reasons, governments want to phase out the huge subsidies they have been giving out to kickstart the electric car industry. And in many cases, there was not a lot of greenery involved in their tactics. It was simply the only method they had at their hand in order to drive down the fleet-wide emissions numbers. And while subsidies have played a very important role, they are fiscally not sustainable and certainly not at the numbers that are required for the industry to truly take off. Little known fact is that the vast majority of car trips are actually rather short. So, and all the studies seem to say the same, that 100 miles of range would be sufficient for over 95% of all driving needs. So as a OEM, you would be forgiven for building a product which covers this 95% and give your car a sensible battery pack to take care of that. So, yet the reality is that less than 1% of the mid-range market is taken up by these electric cars, and there are over 10 models available that more or less cover this 100-mile range. So what really happened here? And then there's the Tesla Model S, so this single model, the best-selling luxury sedan. It takes up by itself 8 or 9% of the luxury market, and it comes with 250, 300 miles of range. And even though also the typical Tesla driver barely uses more than the 10% of their capacity. So like literally 90% of the typical Tesla battery capacity goes unused on any given day, most of the time. So while range anxiety, it's a very real problem, it still is not the most important barrier, according to us. So people still see their car as an investment in a durable good, something that should cover all foreseeable needs in terms of destinations that it has to be able to reach. And a huge battery pack combined with a supercharger network fulfills actually that need, something which Tesla accurately foresaw, which is why they are so successful. And it turns out that people are willing to pay really an enormous premium to cover 5% of their typical need. And it's actually this inefficiency that provides the biggest opportunity for improvement. So Tanktwo proposes a solution where the consumer is left with the choice of deciding how much capacity they expect to use on a daily basis, and then add a large but not a ridiculous margin on top. And the 100 miles which the other players have come to conclude to be reasonable is actually quite a good number, so we're going to use this as a recommendation as well. So the difference here is that the Tanktwo solution provides variable battery capacity, meaning that you have a car which can, for example, hold 100 kilowatt hours of cells, but it is typically fitted with approximately a quarter to 1/3 of that. And the Tanktwo string battery, which is the container, so to say, tank if you will, is partially filled with small egg-shaped string cells, which cover your typical need, plus then this margin of, say, 200 or 300%. But when the need arrives, say you want to do a road trip, extra capacity can be taken on. So on this process, which is very much like a gasoline pumping experience, it takes literally less time than buying gas. So not only can the capacity of the string battery be boosted to about 100 kilowatt hours or so, depending on the size of the car, but a discharged string battery, say you run out of electricity or during a road trip, can equally quick be refilled with freshly pre-charged cells. So this means that the problem of range anxiety can go away, but more importantly even, we think that the battery pack can be used more efficiently because the need for permanent over-dimensioning goes away. So for a typical Tesla Model S, this is about 10-1, and it's actually very easy to get to this number. So if you take an average 12,000 mile a year, this works out to about 33 miles a day, a little bit less. And if you have a Tesla which has 300 miles of range, you can see that almost 90% of the capacity goes unused on a daily basis if you charge every day, which practically everybody does. So in numbers, this means that the Tanktwo powered car can be produced at a price which is in line with what the mid-range market is expected to bear. And if we compare this to a standard fixed monolithic pack, in 2022, a range of only 250 miles, which is not even the 300, will still suffer from a gap of about $5,000 above what is considered an acceptable market price. Here you can see how the Tanktwo string cell stacks up against the industry standard 18650 cell. The battery chemistry which we use is commercially available, so for all intents and purposes the capacity, weight, volumetric density and so on is pretty much the same as a cell in a different form factor. Our string cell is a little shorter and a little fatter than a standard 18650 cell, but the amount of active material inside is pretty much exactly the same. So also per kilowatt hour, the string cell follows the same price erosion curve because, well, it's made of the same stuff essentially. And the string cell contains an extra chip which takes care of all the intelligence and makes the system work. For the first few million cells, this is assumed to cost about 20 cents more, but is expected to erode to 10 cents, and on the long term even zero compared to a dumb cell. In a nutshell, these are the Tanktwo string battery benefits compared to a standard monolithic battery pack. The pack capacity is variable, as discussed earlier, so you can have, let's say, 20 kilowatt hours for day-to-day use, and you can rent another 80 kilowatt hours for a road trip. So such a thing drastically affects the sticker price, and of course it also decouples the price of the electric car from the price of the battery, meaning that people do not have to decide at the point of purchase how much capacity they are ever going to need. Second big benefit is that a full cell swap takes about 60 seconds. We typically claim 3 minutes in public forums, but tests have indicated that it's going to be a lot faster than that. And this is done with mature pneumatic conveying systems, which transfer thousands of batteries as a bulk solid. So it literally is faster than buying a tank of gas, as I said earlier. Also, string cells work much longer than traditional cells, even though that the battery chemistry is the same. And the reason is that in a traditional battery pack, end of life is determined by a certain cutoff number, which is typically 70 or 80%. In case of a string battery, because the cells can work down all the way to essentially zero capacity, so there's a number of extra cycles that can be gotten from them, or they can be worked harder. Also, there is the option now for having pack capacity repair, which means that you can, at a certain point in time, for example, restore the capacity of a battery pack from a number that is the same as when the battery pack was new, and probably even a lot more, even if the customer would have bought a full capacity pack, simply because of the naturally evolving technology curve. So later, when better cells become available, they can replace the older cells that are worn out, and therefore the pack gets stronger over time. Also, what is possible is that the cells can be pushed much harder, because we can deal with a situation where some cells actually fail, so they are pushed over the edge. But when the individual cells fail, the impact on battery performance or battery pack performance is essentially minimal. Therefore, the algorithms can be much more aggressive than the ones that are used in packs where the connections between the cells are hardwired. And then a very important final part is that we're able to provide an intrinsically safe system, and a chain reaction can be prevented by a mechanical dispersion in case of an accident. So, and you can see this, for example, as an airbag for your battery pack, meaning that if a situation would occur where there's a potential for a runaway effect, essentially a battery fire, an airbag would blow up the tank, and it would disperse the string cells on the road in such a way that a chain reaction is physically no longer possible. So the Tanktwo string battery is the only battery at this point in time that exists which is intrinsically safe. Looking at how the industry has been evolving, it's clear where the trend is. So Faraday Future, for example, well, we think that they saw the light as well, and they announced a modular approach for batteries, which we think is a step towards fully intelligent, flexible and distributed batteries. Faraday Future will be able to implement certain improvements with their system, but we think that the Tanktwo string battery is where everybody will essentially end up at. The key things of that are, of course, the smart cells, which can change owner and are tradable as a commodity, a little bit like a shipping container, so to say. Battery packs that can be repaired and serviced instantly, so that degraded performance can be restored in a matter of minutes, worst case. Also, smart system which allows for billions of combinations between the cells. That means that there's always a way to get the last drop of juice out of the pack and to get the last amount of capacity out of the system. And then there's the intrinsic safety thing, which we talked about earlier. So no battery fires, that's a big deal. And then there's the pumpability or the cell swap. It's a big deal for consumers because you can go in a very short period of time from a flat battery to 100% charge. And yeah, the market will certainly appreciate that. And since Tanktwo is essentially an IP company, of course it needs decent patent protection. We have used one of the world's best IP firms to make sure that our protection is sound. And pretty much every important part of the system, as I described it earlier, has been patented, and we can choose to enforce it if that is in our interest. Now, we think that the Tanktwo string battery is the only technology that covers the needs of the consumer who pays the bill at the end of the day, the existing and emerging industry players who will need to do certain implementation, and then the governments who still have to meet their international obligations without having to throw billions of dollars of subsidies at the problem. Tanktwo works with a few key industry players who are an essential part of the system's overall success. For example, we work with Valmet Automotive, who designs and manufactures cars and car components. They're working on the vehicle side of our solution. Zeppelin Systems, which is the global leader in bulk handling of solids. They're working on the cell swapping and infrastructure side of the solution. And there are a few other players which we are not able to announce the cooperation with yet. Finally, Tanktwo is progressing rapidly with the global launch implementation. Working early prototypes are available for potential customers who need it for evaluation purposes, and we are still open for a number of partners for the global launch in early 2017. So if you run a business in a field where batteries need to be used more efficiently or where their cost needs to be brought down, or if you work in the energy retail or distribution field and you want to have a piece of the pie of the EV sector, or trading of energy carriers could be your focus area, for example, companies with a financial background. Or if you, for example, analyze energy trends, you trade energy and things like, for example, optimization of generation or grid load would be in your interest. So perhaps we should get in touch. So I hope that you learned something from this very late night video. My email address and my phone number will be coming up again, and I really hope that if there's somebody who considers this interesting and sees opportunities for cooperation, we'll get in touch. Waiting for your call. Thank you. Bye.